Chromatography is used to separate constituents of colored mixture from its substance. It's used to separate constituents of colored mixture from its substance. We have types of chromatography. We have paper thin layer chromatography, gas chromatography, and column chromatography. We use paper chromatography to separate constituents of a dye from a mixture or from a colored mixture. While gas chromatography, we use it to separate complex gases from each other. And we use column chromatography to separate colored mixture from dye, leaves, or ink. That is what we use column chromatography for. And chromatography, there must be a phase. We have two phases during chromatography, which are the stationary phase. This stationary phase may be in solid or in a liquid state, where the adsorption of substance occurs. That is the stationary phase. We have the mobile phase. The mobile phase is the phase that carries the colored mixture to the stationary phase. And I spoke about adsorption. Under chromatography, adsorption is so important. What does adsorption mean? It is a process by which a substance is attached to the surface of a liquid or a solid. It's called adsorption. It's called adsorption. We have some things to talk about under these separation techniques. We've spoken about state of matter. How could we identify maybe a substance is pure or impure? That is why we talk about criteria for purity of pure substances. Under this, there are physical states that makes you determine maybe your substance is pure or impure. These criteria are the density of that substance, the melting point, the boiling point, and the freezing point. How do you determine the density? The density of a substance is sharp and definite. That was all these things. Criteria, they are constants. Each substance has their own density, boiling point, melting point, and freezing point. This density is sharp, and with this density, you know maybe the weight of that substance, how light or heavy that substance is. For example, we have maybe sodium chloride that the density is around 801. If that density reduces to around 700 and something, it's telling you that that substance is not a pure substance. The melting point. Each substance has its melting point. When the melting point is lowered than the actual melting point, we know that our water melt at is 0 degrees Celsius. When it's not pure, it lowers the melting point. maybe -0, -14, minus so figure is telling us that that substance is not pure. When we talk about the freezing point, it's definite and it's sharp for each substance. Our water too, that one is common, 0 degrees Celsius. Anyone below that is impure. It lowers the freezing point. Let's talk about the boiling point. We all knew that water boils at 100 degrees Celsius. But when you get to a stage that the boiling point increases, it's telling us that that water is no more pure. That shows that constant value has been hotter. For you to identify your substances being pure, their boiling points, you must observe that, the melting point, the freezing point, and the density. Thanks. Thanks for listening to the class. Please subscribe, share, and like. And press your notification button for the next topic, which is particulate nature of matter. Thanks.